Okay, so we have like a few questions, then we'll start with exercise. So first one is here, like we have to solve the differential equation by using variable separable, and we have to determine a particular solution of the equation because we are given some condition also here that y is 3 when x is 2. So let's try to solve this. So first what we'll do, we'll separate the variables as the name suggests. So we can drag this x plus 1 on the right hand side, and we can drag this y over on the left side to get dy over y gives 2x over x plus 1 dx. So sometimes you'll get different answers if you treat this constant 2 differently. Like in one case you can bring this 2 on the left side to get 1 upon 2y dy. Now when you'll integrate this, now you'll get 1 upon 2 log y. Now you know that if you have a term before log y, you can write it as log y ki power 1 by 2, right? So you'll get different answers if you do it like in the different way, but always if you're gonna match the answer from the book, do it like this. Take always the constants on the right hand side. Whatever 1, 2, 3, whatever you have, take always the constants on the right hand side and only the dy and y terms on the left side. There should not be like 10y here. Are you getting
Okay,
my
sir.
point? Yeah, so both the answers are not like wrong. If you do it like this, the answer won't be wrong, but it won't match the book.
Okay, sir.
Okay, so we have now separated the variables. You can see that y variables are on the left side and x variables on the right side. Now what we have to do, we just have to integrate the both sides. Integrating. Now integrating dy over y. And here we can take 2 outside and integrate x over x plus 1 dx. So on the left side, we'll get log y. 1 upon y is like log y. Can you tell me how we can integrate the right hand side, this x over x plus 1?
Sir, can it be done by substitution method?
I don't think there can be. Like if you had the denominator of x square plus 1, then you can like x square plus 1t,
Oh, yeah.
then you'll get 2x. So that's not the case. If you have like even powers, same powers, then you have to decompose. Have you like heard about it? Decomposing the function.
No, sir.
Okay, so how you can do is, uh, let's see. So first see how we can write it. So we can write it like this. 2 over, let me see, 1 x plus 1 minus x. 1 minus 1 upon x plus 1. So as you'll do questions, you'll get it directly. But if you're not getting it directly right now, that's okay. There is a method to do it. So if you see, when you'll solve this, what we'll get x plus 1 minus 1 over x plus 1, right? We'll take LCM here and the x plus 1. 1 times x plus 1 is x
Oh,
plus
yes,
1.
sir. Actually, I have done this method
Yeah,
at school. And my
partial
teacher always
fractions and
adds a plus one, minus one.
yeah. So it like depends on what is given. So there is a method also. You can like do it always, like follow the same method and you'll get your answer. So the method says that we have here x over x plus 1. So what we need to do is we need to like divide it into two parts. So we have to get one part here and we have to like get other part here. We have to write it as the sum or difference of two numbers, but we're always going to same take plus sign. Let's say the second term is negative, so it will automatically become negative. So we need to write this as the sum of two different functions. So how we can determine these two different function is by writing it like this. So let's say the so let's say like, right, we do this like 8 by x plus 1, and we get something here and we get x plus 1. So the idea is like you'll get denominator, same denominator in both. Okay, so how this works is after some like doing some arithmetics, you get to this function. But before it was like something upon x plus 1 plus something upon x plus 1. Then you took the LCM of x plus 1 and do some arithmetic on the numerator, and then you get x over x plus 1. So we are going to unfold it. We're going to write it like it was before. So we assume that the numerator was a here and the second is numerator was b. Okay, so now what we can do is we can write it as a plus b over x plus sorry, yes, a plus b over x plus 1 to get x over x plus 1. Okay,
Yes, sir.
now we can like write as I'm doing something wrong here. Let's see. Okay, next term is a over b plus and bx plus, because one of the term will have x in it. That's how numerator will have x. If none of the terms in the numerator will have x, then how will you get numerator, how will you get x in the numerator? That's why one of the term will have x. So now you can see that we get a plus bx. Okay, so now we can cancel out the denominators to get x is a plus bx. Okay, so if we now compare the coefficients, so here we have a term of x as bx, and here we have a term of x as only x. So here the coefficient is 1, and here we have coefficient b. So these coefficients must be equal. So b is 1. Now a is like there is no constant term, so the a is 0. So a is like 0. Okay, so we get the same thing. Okay. Let me come get back to you with this later. Let's first do our question. I'm getting something wrong here. We'll look at we'll look it at later. Okay, so let's do it
Yes,
here.
yes.
So here you can see that if we solve this, you'll get back to the same the function that we have over here. X over x plus 1 is equals to 1 minus 1 over x plus 1, right?
Yes, sir.
So now we will like easily integrate it. So we'll get 2 times, let's take it outside, we'll get integration of 1 dx, and then we'll get minus integration of 1 over x plus 1 dx. Okay, so 1 dx is like x, so we get 2 times x, and this 1 over x plus 1 is log x plus 1, so we get log x plus 1. So this is the integration of the right side, so we get log y, and we have integration constant at c. So this is the integration. Now we are given a condition also that y is 3 when x is 2. So y is 3 when x is 2. So let's put these values. So we get log 3 equals 2 times 2 minus log 3 plus c. So let's solve it further. You get log 3, and here you'll get 4. So this comes here and get minus 4. Next time you'll get minus 2 log 3. So here you'll get plus 2 log 3. This is the value of c. 2 log 3 and log 3 can be added together to get 3 log 3 minus 4. So this is the value of c. Now we can just substitute this value of c back here to get our not here, here, to get our solution as log y equals 2 times x minus log x plus 1 plus 3 log 3 minus 4. So this is our particular solution for the differential equation. Okay.
Yes, sir.
So while solving the equations, the important thing that you want to like remember is how to integrate different functions. So integration is the most important part when you're solving the differential equation. When you're checking whether a solution is from the differential equation or not, the important thing is like differentiating correctly. But here, when you are going to solve, the integration part is important. So now let's take another problem. So let's say we can do this like dy over y plus 2. Okay, let's write it y over y plus 2 dy gives x plus 2 over x dx. So this is how we can like separate variables here. Now we need to integrate both sides. So we can integrate both sides. So this time integrating, so how you can integrate the right side first? Let's talk about right side. How you can integrate this side?
So do I take the x up,
X up like, I don't get.
like as a negative power?
So x by 2 upon x is x plus 2 x minus 1. Okay, next. Now what will do? How you can integrate this?
Um, I don't think you can.
Okay, so if you did this part, you can do one more thing. You can just multiply this x now. So you take this x, open the brackets. So you get x times
Hmm.
x inverse plus 2 times x inverse, right? Now what is x times x
Yes.
inverse? What is this?
This is x to the power 1.
No, x to the x inverse. So if you like remember a to the power m into a to the power n, what is this? A raised to the power m plus n, right? If you
Oh
have the
yeah, right.
same
It's
exponent,
1. It's 1.
so here you'll get 1 plus minus 1. So this is like
Yeah.
just x to the power 0. This is just 1.
0. So it's 1.
Or you can like see that x is the inverse of x inverse. So you can also see that x inverse is x into 1 upon x. So you cancel this and you
Yes.
get 1. And what is
Yes.
2x
Yes. I got
inverse?
it.
This is just 2 upon
2
x.
by
So 2
x.
upon x is 2 log x. So right side you can integrate. So how you can integrate the left side? Left side is different.
Is it like the previous sum? Like,
Yes, yes. So in the left side, we have to like do what we did in the previous. So let's see how you
yeah.
can write this. So y over y plus 2. How can you write this as the sum
1
or
minus
difference? 1
1
minus.
minus 2 by y plus 2.
So y plus 2 minus 2 is will cancel out and you get y by 2. Okay, so this is right. So you can like if you want to like do this, let's take 5 minutes or 3 minutes, 3 to 4 minutes, and try to like do this. Then we'll check what both our answers are. Okay.
Yes, sir. Sir.
Yes.
Sir, is it y minus 2 log y plus 2 is equal to x plus 2 log x?
Yes, yes. So this is the, okay, so you get it right. Now let's move to the exercise part. Let's solve exercise 8.4. So the first question is like x cube, is it x cube? This is kind of blur. X raised to the power 5. So x raised to the power 5 dy over dx is minus y raised to the power 5. So this is now like pretty easy for us. We can just separate the variables as dy over y minus y5. This is plus, and we get minus dx x5. So integrating both sides, we get log y raised to the power 5 is minus log x raised to the power 5. Oh, wait.
Oh, sir, I thought you couldn't take log for that.
Yeah,
So I
yeah, yeah.
thought you should inverse it and then do the
You
plus
couldn't.
one.
You're right. Yes, yes. So you can write it as y raised to the power minus 5 like this. Then you can integrate is at y minus 4 divided by minus 4. So you get both sides as y minus 4 divided by minus 4 and minus y minus, sorry, x minus 4 by minus 4 plus c. So this minus cancels out and we get y minus 4 equals minus 4. So minus 4 and 4 will also cancel out. So you get minus x
Cancel,
raised to
yeah.
the power minus 4 plus, like you can write 4c, but that's also a constant. So we'll write just as c.
C. Yes.
So the answer is like y minus 4 plus x minus 4 equals c, which is exact same. So next question is, similar to what we did in our like previous example. So this is x times 1 plus y square dx plus y times 1 plus x square dy equals 0. So we can first write it as y times 1 plus x square dy equals minus x times 1 plus y square dx.
So I can
Okay.
also take the y into 1 plus x squared that side, right?
Yes, yes, you can do that also. But like to match the answer, okay, sometimes the answer will be match if you do it like anyways, but sometimes what happens is when you encounter questions involving log, so that way, that time, and sometimes when you have to go for the particular solution, then the answer sometimes like don't match with the answer, because if you take log, like if you take the constant on the left side and y on the right side, so it like changes the answer a little bit. So it's
Okay,
it's
so I
like
should like make sure that it's always x on that on the right side and y on the left side, right?
yes, yes, because solution was like when we talked about solution, it was like y equals fx. No, so it is always like y equals to something of x. So solution is
Yes,
always
yes.
going to be like this. So that's why we are writing y on this side. So it's like a convention. It's not wrong to like it's write it as x equals to y something plus c. It's not wrong that we write this, but it's a convention that everyone follows. The book is going to follow. So that's how we're going to like proceed. Okay.
Okay, sir, got it.
So we can now write y upon 1 plus y square dy and minus x over 1 plus x square dx. So how we can integrate here?
Also, since it's like y square and x square, for this, do we use substitution?
Yes, here we can use substitution. So if you put 1 plus y square as t.
is equal
We'll
to
get
t. Yeah.
2y dy as dt, and we get y dy as dt by 2. So here also we can like substitute for another variable. 1 plus x square gets z. So we get x dx as z, sorry, dz by 2. So we'll put these two values to get dt 1 upon 2 integration of
2t. Then
2t. We are going to like replace y dy by dt by 2. So y dy becomes dt by 2, and this 1 upon y square, this becomes t. So we get 1 by t,
t. Yes, sir. 1 by
right?
t.
Here we'll get similarly 1 upon z dz. Okay, now we can integrate both sides to get 1 upon 2. So before
Log
integration, we
t.
can cancel these 2's. Okay,
Yes, sir.
so we get like log t
Log t
equals minus log z
minus log z.
plus what we'll get here?
T.
Constant. So in this case, we're going to take constant as log also.
Oh, okay.
Okay,
Because everything has
because
a log.
yeah, because everything has a log, so we're going to take it as log also. So now
Oh,
we substitute back the values of t and z. So t was 1 plus y square. So we get log 1 plus y square equals minus log of 1 plus x square to get plus log of c. Now we can further simplify this. How we can do that is here you can see that you have 2 log and these are subtracting. So you can use the property. So the property of log is like if you have 2 log terms and they are like same base. So here you can see the base is same. So what is the base here actually? If you can, at what base we are taking these logs? Do you know? So there is like a base to the log. So log base AB. This is the representation of log. So log is
oh yeah.
always taken at some base. So this is called the base, and
Yes.
this is just the number that we're going to take the log for. So what is the like base here when we are taking that log t? What is base here? So if
It's
nothing is written, it's like natural log. Okay,
yes.
natural log is written as ln. So sometimes in some books you'll see that it is written ln, not log. So ln is not nothing, just log of natural base. Log of e is ln. So now we can use the property of log. So this says that if you have two logs, log same base, log a and minus log b. So what you get is log a
Log
by
a
b.
divided by b.
And if you are taking log a plus log b, then you get
Log a
log
into b.
a into b. So here we can write it as log c over 1 plus x square, because 1 plus x square is the one who which has a negative sign. So whichever has the negative sign goes in the denominator. So 1 plus x square goes in denominator. Here we can just write log 1 plus y square. Now we have log on both sides. So like we can cancel this
Cancel, cancel.
cancel this log, but like it's not, log never cancels out. You what you do here is you take anti-log. So how to remove
Anti-log.
log? Yeah, you take anti-log. So whenever you like, you have to write some like some words here, no, in the exam. So what you'll write is taking
Taking
anti-log
anti-log on both
on both
sides.
sides. So you get 1 plus y square. Why is it 1 plus y square as c by 1 plus x square? So this can be written as 1 plus y square times 1 plus x square
X
gives
square
c.
is equal to c.
So this is the answer for the next problem. So now
Yes, I got it.
let's see second one. So this will be like solved directly. If you see the second one is dy over dx. So we'll just write, not solve here. So dy over dx is x plus 1 over 2 minus y. So this will be like directly 2 minus y times dy gives x plus 1 dx. So everything is numerator. So directly you can integrate and solve, right?
Yes, sir.
So this can be done now. We'll skip this. So next is e raised to the power y minus x dy over dx is 1. So how you can separate the variable here? Do you have any idea? So here again also we are going to use the same property of numbers, exponents, that says if you have an exponent written as a raised to the power m minus n, so this must be written as a raised to the power m divided by a raised to the power n, right? That's how you get this
Yes, sir.
exponent. So this e raised to the power y minus x can be written as e raised to the power y divided by e raised to the
Divided
power
by e
x.
raised to power x.
Now we can just separate the variables to get ey dy gives ex dx. Right, now
Dx.
it can be integrated. So integration of ey is just ey
Ey is
and
equal to
ex
ex
plus. Now
plus c.
what you will take constant? So in
I
this
know for a fact
case,
that it's not c.
yeah, this time we'll only take c, not e raised to the power c. Like, so if we take like e raised to the power c, nothing can be solved because there
Yeah.
is no properties that says that if e raised to the
E
power x
raised to
plus e raised to the power c is written, then you will write it's like simplify it further. There is
Yes.
no property. So that's why we're going to take it is only at c, because taking it
Just
as
c.
e raised to the power c won't give us anything.
Yes,
So
sir.
in log case, because you see how to take constant, we are like have full power to take any constant. Constant is anything. So if we take constant as e raised to the power c here also, so that can be like true also. We can give some value of c to get that c back. Like if we take, like if you see how you can take, how you can get back to c. So if you write c as something as log, let's say there is another constant log d. So you write it as log d, and when you have e raised to the power x log, the e and log just removes itself and you get d.
Get
So again you
cancelled
can,
and d.
but
Yeah.
writing it as e raised to the power c won't benefit us at all. So that's why only we are not writing it.
Okay, sir.
So next is dy over dx. So this is our third one. Dy over dx is e raised to the power x plus 1 times y. So this is pretty simple also. We can just directly just variable separate it. So this can be written as 1 over y dy gives e raised to the power x plus 1 dx, right? So you get log y here and you can integrate it directly there.
Yes, sir.
And it's in the second part. Oh, sorry, this was the first part. So in the second part, the question is dy over dx plus 1 plus y square over y gives 0. So here also we can uh, just write it as y dy over 1 plus y square gives minus dx, right? Is this correct?
Um. Yeah. It's correct.
So first you take it on the right side to get negative, and this y goes up
And
and
then
this 1 plus y.
yeah.
So here you can see that this is substitution. Put 1 plus y square at something, you get y dy,
D.
and minus dx is like pretty simple. So this
Yes, sir.
also we'll skip. So next let's take a look at fourth one. Fourth one is 1 plus x square dy gives xy dx. So we get 1 over y dy, and here we get x over 1 plus x square dx. So this is also like the last part. On the right side, you have to do substitution, and on the left side, it's
Left
just
side
the,
is log.
yes. So it's second part. Let's see its second part. It's xy y dash gives 1 plus x plus y plus xy. Sorry, I have a cold. So
It's okay, sir.
in the first step, like you can see that you have 1 plus x here, and if you take y common, you have 1 plus x here, right? So
Yes, sir.
let's write it as 1 plus x plus taking y as common, we'll get 1 plus x here also. Or something is wrong
So
in
it'll
my
be 1
board.
plus x into y plus 1.
Now we can like take 1 plus x common from both terms to get 1 plus y. So now it's like in the factored form, so we can directly like variable separate it. And here we have xy dy over dx. So we get y over 1 plus y. Y over 1 plus y dy gives 1 plus x over x dx. So now how can you integrate it?
So for the left hand side, it's the y plus 1 minus 1
Yes.
technique.
So on the left side, what we can do is plus 1 minus 1 dy. And on the, yeah, now I remember, like if you have this type of term, you can directly do it like this. But if you take, like, let's see, you have x square plus 2 over 2x plus 3, this type of term. Now you have to like write it in two terms. That's where you decompose this. So whenever the question comes, we'll do it like that also. So on the left side, we can just directly remove, like if you have a number like 2 plus 3 over 2, so you can write it like 2 by 2 plus 3 by 2, right? Because you have a common denominator now, so you can like
Yes, sir.
give denominator to both the terms. So here also we have a common denominator x on both the terms 1 and x, so we can write it as 1 plus
It'll be
x plus
1
1.
minus.
No, here no, we don't have to like plus minus, because the denominator is less and numerator is like more terms. So in this case, just write it like this. But here we can see that denominator has more terms and numerator has less terms. So see, there is a difference. If you see that if we have 2 plus 3 over 5, okay, so you can write it as 2 by 5 plus 3 by 5. This is correct. But if you like reverse it, you have 5 over 2 plus 3. Then you cannot write it as 5 over 2 plus 5 over 3. This will be wrong. Like if you write
Yes,
it
sir.
as this. Okay, so there is a difference. So you have to like see. So here on the right side, we can like remove this x on both the terms 1 and x. But here we cannot do that. So now when we have plus minus 1, now let's see, we take this as one term. Let's consider it this as single term, and let's consider 1 as single term. So now we can write y plus 1 over y, that this is y plus 1 also, and negative 1 over y plus 1. Okay, so this is the, like this is how you will write it, and here you can directly integrate, so no need to change here. This is dx. So this comes to be 1 minus 1 by y plus 1. So from here also, from here the question is like similar to what we did like before. So let's quickly jump to next question. So this can be done. Next steps you can do now.
Yes, sir, I finished it.
Okay. So next we have find the particular solution of the differential equation dy over dx gives minus 4xy square given that. So let's do this. So we have the differential equation is dy over dx minus 4xy square, and the condition is that y is 1 when x is 0. Let's try to solve this. So you get a dy over y square gives minus 4x dx. Next we integrate this, integrating both sides. Why? So y minus 2 is y minus 1 by minus 1, right? Gives us
Yes, sir.
minus 4x square by 2 plus c. So now we can substitute the given condition. So substituting y equals to 1. So we'll get on the left side minus 1, and substituting 0 on the right hand side, you will see. So the value of c is minus 1. Now we can just substitute c minus 1 back here. And also like we can, every term now we see has negative. This y also has negative, this x and this also. And this cancels out. So what we can do, we can take, okay, my pen is doing something weird. So what we can do is we can take this negative out from every term to write it as 1 over y gives x square 2x square plus 1, or we can like write it as 2x square y plus y equals to 1. So whatever is given, sixth, y equals 1 by 2. So you can reciprocal it here also, you get y equals 1 over 2x square plus 1. What is wrong with my pen? Y equals 1 by 2x square plus 1. So this is the solution. So we have, let's cover last question also quickly. We have seventh one. So 2 times y plus 3 gives, oh sorry, minus xy gives 0. And the given condition is that y1 is 2. Okay, so we can write as xy, uh, xy dy over dx equals 2 times y plus 3. We can write it like this.
Yes, sir.
So now we can write y over y plus 3
3 dy is
dy
equal to 2
2
sorry, 2 dx
dx.
divided by x.
Okay, so on the left side, what we need to do is plus minus 3.
Yes, sir.
So we'll get 1 and
Minus
minus
3 by
y plus 3.
y plus 3 dy.
So let's quickly integrate. So we'll get y minus 3 log y plus 3.
Is equal to 2
Something is
log
wrong in the
x.
middle part of the board. Always here when I coming here back, the middle part it's doing some weird thing. So here we'll get 2 log x plus, let's take only c. So what should we take? Should we take log c or only c?
Only c, sir, because the first y term doesn't have log.
Yes, yes. So next, now we need to just substitute the given condition. So given condition was y1 2. So y1 2 means x is 1 and y
X
is
is 1,
2.
2.
So 2 minus 3 log 5 gives us 2 log 1 plus c. So what is the value of log 1? Do you know what is the value of log 1? So
No,
log 1
sir.
is like 0. Like there are some log which like log 1 is 0 and log 10 is like 1. Okay.
Oh,
And whenever like you get like something is written like log 2, and let's say the base is also 2. So whenever this happens, that exponent and the
it's
base is
one.
always like same, it's always like going to be 1.
One.
So here also why log 10 is 1, because we have like 10 base. We are talking about 10 base. So and like if you do log 10 square, so you'll get 2. If you do log 10 cube, you'll get 3. Why? Because this exponent just comes in the front, and this log
Yes,
10
sir.
is 1, so you get 2 into 1. So we can just like solve it little bit more to get this is 0. So c is 2 minus 3 log 5. 2 minus 3 log 5. So let's substitute back. So we'll get y minus 3 log y plus 3 will give us 2 log x plus 2 minus 3 log 5. So let's check what is the answer given. So they are converted to e raised to the power something. So we have to solve it like little more. So let's okay, so we can write it as log y raised to the power whole cube, and here we can write log x square, and this y will be like okay. So what we are going to do is take the log on one side and take non-log terms on the other sides. So
Okay, sir.
this will become minus log y plus 3 की power 3 and minus log x square and plus 3 log 5. So we'll write it as log 5 raised to the power 3, and here we'll get 2 minus y.
Yes, sir.
Right, so now we can simplify these logs because all are like the same base. So this will get log uh, 15 5 by 25 125 over y plus 3 and x square, right? These two are the negative ones, so these will go in the denominator, and 5 cube is the positive one, so this will be in the numerator, and here we'll get 2 minus y. Okay, so
Yes,
now
sir.
what we can do, we can change, we can shift this log on the right side. So when we do that, everything that is in the right hand side just becomes in the exponent. So we get 125. So I can see 125 is not in the answer, else is like right. So what we have done wrong? So lock. Okay, we have taken the wrong value here. Y
Where, sir?
y1 was minus 2, and what we have taken is y1 is like we have written 2.
Oh, we're
So
right.
instead of plus 2, we have taken instead of minus 2, we have taken like plus 2. That's why we get getting. So you will do like
So
this
it'll
on
be
the
3 log
okay
1.
home. Yeah, so this will like uh so minus 2 will be like here minus 2. So we'll get log 1 here also, right? If we like
Yes, sir.
take minus 2, so we'll get minus 1. which is like just log 0 also. So you'll simplify it. Now let's simplify this here. So what here we'll get is y plus 3 whole cube x square gives e raised to the power 2 minus y. So now we can just reciprocal it to get that y plus 3 whole power cube x square is, now when you reciprocal it, this will become like e raised to the power y minus 2, or you can write it as 1 upon e raised to the power 2 minus y, both are same, and 125 in the denominator.
Yes.
So if we had in like taken plus 2, this 125 wouldn't be here, and the answer would be like matched.